Good morning, good evening, as per your time zone. Okay, so any questions before we start? So today, anyways, we will be covering the architecture for Postgres. Okay, that would be our first lesson on Postgres, and then we'll continue installing another stuff on Postgres. Okay, today would be only theoretical session on the Postgres part. I hope everybody can hear me. Can you anybody confirm on the chat window once?
I can hear Arnav.
Yeah, we can hear.
Okay, okay. So then let's begin. Okay, I think this is the diagram which I showed on that day as well, on the demo session as well. Okay, and I think most of the guys are DBA. You might be understanding all the stuff of shared buffers, val buffers, and process arrays. So let us go once more, maybe. Just give me a second. Okay, so this is the process, the main process for which is known as the postmaster process. Okay, and the name you can understand with the name is a postmaster. He is sending or is uh, receiving the connection and then passing on it to the next person. Okay, that is the function of the postmaster. So whenever a user makes a connection, maybe I can just say user here. Whenever a user makes a connection, he makes a connection to the postmaster process. Okay, he makes a connection to the postmaster process. Now this master process, all this database cluster, he sends the message to that database of what we say Oracle database. Okay, Postmaster is the individual process for one database cluster. Okay, so I don't have multiple databases or multiple such thing getting registered within myself. Okay, so one cluster, one Postmaster for that particular cluster. Whenever I'm creating a cluster, a Postmaster is created for that. Okay, so but now each individual database cluster definitely has multiple databases. So the person will provide me the username, the credentials, and my port number of the postmaster, the IP address where postmaster is running. Okay, and then it will go ahead and will connect to this shared memory. Okay, we'll go ahead and connect to the shared memory. So now if I talk about a simple maybe I'm just opening a notepad, a simple select statement, maybe, right? Maybe a simple select statement, select star from school. Okay, so select star from school, a simple select statement came coming in. This will go to the shared buffer because it is asking for some data, so it will go to the shared buffer. Okay, it will go to this shared buffer. So now postmaster will send the request to this shared buffer. Okay, so this it will try to get the data from the shared buffers. Okay, try to get the data from the shared buffers. If it gets the data from the shared buffers, that means it has been a read, a logical read, okay, from the memory itself. Otherwise the data is not there, assume it will go to the data files. Okay, so data is stored in the data files. It is physically stored in the data files. Okay. Okay, so it is getting physically stored into the data files. Okay, and the next kind of query can come in. Okay, and once it reads from the data file, it will fetch the data from the data files, again come back to the shared buffer. So shared buffer will now contain the data, okay, the school data, and it might be some, maybe might have some where clauses, might be have something, what we say, maybe a where clause is there where grade is equal to something like 9 or something, right? It might be have something, right? This, okay, so it'll do all the such kind of formatting, okay, and then it will return the data to the user. Okay, so this is how a select statement works in a Postgres. Okay, so everything, the query generation, what we say, the parse tree, what we call the execution plan, uh, everything is contained in the shared buffer. There is not a separate pool for it. Okay, there is not a separate pool for it. Okay, so your parsing tree, your execution plan. So what we have is a library cache kind of a term in Oracle. Okay, everything is be contained in the shared buffer itself. Okay, the data as well, the metadata as well, everything is a part of a shared buffer itself. Okay, there are no separate pools for it. Everything is being contained in the shared buffer itself. Okay, next, next comes the change. Okay, next comes the change if occurring. Change, you can say, is the update statement. Maybe I am updating school. um, Set grade is equal to 10, where maybe I think the same example I took on that day as well, where roll number is equal to 10. Now this is a change that is occurring. Same, the user will send the request. Okay, now once a connection is made, okay, so once a connection is made, now you can say user is directly connecting to this shared memory. Okay, he is not making any connection to Postmaster, just like a listener. Once it is connected, it is now making a direct connection to your shared buffer because it is connected to a particular database now. Okay, so now again, same request of update comes in. Update school set grade is equal to 10, where roll number is equal to 100, something like this. A request comes in. Now this is a change. For a change, what will happen? What will happen? Now this school anyways is there in the shared buffer because just we have accessed. Maybe it is not there. The same process will happen. We'll go to the data file, fetch the school from here. Okay, assume the school is already there, then it will make an update on the school. Okay, wherever the roll number is 100, it will make it 10. Okay, so my assume roll number is a primary key over here. So now this record, this is a record. Okay, now this is a change record. Okay, now this is a change record, so a change has been occurring in your database. Okay, so database has a property to record all the changes that is happening in your database. Okay, this is used for your backup and recovery. In case any database failure occurs, then this is used to recover your database. Okay, so what will happen, the record of change will be happen in your database. Where it will happen, it will happen in val buffers. Okay, it will happen in the val buffers. Okay, it will happen over here. So val buffer is known as the write ahead. Okay, I will write it here, that will more convenient also. Okay, I will say write ahead log file. Okay, this is known as write ahead log file, WAL, write ahead log file. So this is will be storing over here. Now what will store in the format, it will store the primary key, maybe the roll number 100, and the old value grade 9 and the new value grade 10. So it will store in this way, val buffers. Okay, so now val buffers, when a change has been occurring, so it will write it in the over here. Okay, now to make anything permanent in database, what we do, we commit, right? We commit a transaction. We might type commit, or maybe it's an auto commit. Okay, auto commit means is in Postgres that every statement will come with a commit. Okay, so it might be an auto commit, and might I need to commit it manually. Okay, Okay, so it might uh, commit, you might commit manually. Okay, so or might be not to commit. So whenever you commit, this change will go to the val segments. Okay, this change will return to the val segment. Okay, and which process will help me? You can see this val writer. Okay, val writer will help to write the changes into val segments. Okay, so this is going to help me to write to the val segments. Okay, so the commit will occur at this point, and thus now this change is permanent. Okay, I cannot roll back this change. Once it is commit, you cannot roll back. I think this is all DBMS principles. So it has been commit, so it is written to the val segments. Shared buffer also has occurred some changes, right? Update school set grade is equal to 10. So this school is updated over here, but not updated in the data files. Okay, not updated in data files. It is updated in the buffers as of now. School data is updated in the buffers. So now this change is also be saved into the data files. Now who is going to write? BG writer going to write over here. Okay, background writer will write all the changes from the shared buffer to the data files. Okay, this is the benefit of the background. And when it has to write, it will write at every checkpoint. Okay, this is a checkpointer process. One more process on the green. Okay, this is the checkpoint process. Okay, so this is the checkpoint process that is going to write from that is a point, that is a trigger. When this trigger will occur, this trigger will help the shared buffers to write to the data files. Okay, so now this trigger will occur at some moments, at a few seconds. There are a lot of triggering events which we'll study in the later chapters. Okay, now this process array is containing the all the processes. Okay, because all these processes will also take some space, so I'm giving all this space into within the shared memory itself of the Postgres. Okay, so this is about the shared memory. Okay, there would be some private memory as well, very very similar to what we have in Oracle also. I hope if everybody's in Oracle DBA, then we're going to understand it easily. So we have a private, I'm not specified in this diagram, but there will be some private memory as well. So now this shared memory is shared by all these sessions that are connecting to the database, and private memory is private to every session. Okay, is private to every session. So every session will have its own private memory. For so last sorting hashing, so last kind of sorting and hashing is required, last cleanup job or last uh, kind of activity is done in the PGA, or not PGA, it is known as the private memory. So now last time it will return from the private memory, not from the shared memory. If any sorting, hashing or something is required, so it will return from that. So that is linked to each session. Okay, we will see in the next diagram actually. Now let us understand these terms as well, which are over here. Error log files. Error log files is the all the files which are just a minute, everybody. Uh, Saurabh, are you recording the session as well?
Yeah, he's recording.
Okay, okay, okay. Fine. Okay. So error log file is also is the set of files which is used for reporting, for log, for all warning, informational messages. Okay. So now this is written by the log writer. Val writer is anyways writing the val segments. Now there is a concept of archival. Okay. So archival. Let me go back to the notepad. Okay. Let me clean up this. So what will happen to the val? And now now here the concept is val segment has some particular size. Okay, by default it is one GB, and the size of each val file is almost 16 MB by default. Okay, I can definitely increase it, decrease it um, uh, as per my interest. I can increase it, decrease it. So size of each file is 16 MB, and total size I can allocate is 1 GB. So what will happen to val file? So I think you can divide 1 GB of 16 MB. I don't know what's the figure. Okay, assume it is somewhere around 100 files. Okay, so what will happen? It will keep on writing. Okay, I know it is not might be 100, it is might be 50 or 60. Okay, I assume 65s. Okay, so it will keep on okay, so it will keep on kind of writing the file. So once a val file is written, okay, first file is written, it will move to the next file, right? It will move to the next file, very natural. 116 MBs will move to the, so now this val file will be copied, okay, will be copied to the archive file. Okay, archive log file. Okay, okay, archive log file. This is not by default. You have to enable the archive log. Okay, you have to enable the archive log. Otherwise, a val file will keep on writing, and 160 files are written, it will start overwriting the first file. Okay, it will start overwriting the first file. Okay, so if you see over here the difference, okay, if you are coming from Oracle background, okay, there the concept of members and groups and members, right? There one group can contain multiple members. There's multiplexing. There is no multiplexing. Okay, don't ask for multiplexing. Still now, Postgres doesn't have any multiplexing. They have a control file as well, which is not specified in this diagram. Okay, I'm not sure about other databases because I am only for I have only done Oracle database before Postgres. Okay, so maybe you can compare with your database you're coming from. Okay, so it doesn't have a multiplexing, even control file. So control file is kind of a manager kind of, which has all this checkpoint information, name of the database. The control file is also a file which is for the complete cluster, not for complete any particular database, for the complete database cluster. So there is no multiplexing over the control file as well. Okay, so maybe in the future they might bring such features. Okay, right now there is no multiplexing, so it is writing only to one val file. So definitely there is a risk if that gets corrupt, then definitely Postgres will get down, because val files are quite important to be. So that can cause some ways loss of data as well, but as of now there is no multiplexing feature over here. So I hope you understand the concept of val file moving to archive file. So once a switch happens, once val file is being one val file is being completed and it moving to the next file, it is copying to archive log file. Okay, you can see over here there is an archive val file. Okay, so archive val file is copying to the archive val file. Okay, one more concept of it's vacuum process. Okay, okay, you can see over here auto vacuum. Okay, anyways, we'll go through much details. I'm just telling you the concept. About the parameters and other things, it will be coming in a chapter which is the maintenance. Okay, performance tuning and maintenance of Postgres. Then we'll study about different parameters of vacuum auto vacuum process. Okay, so right now I just want to tell you the concept of the vacuum process. Okay, so the concept of vacuum is what is the concept of vacuum is that that what happens is, whenever I update, I hope you have told you, whenever I try to update, right, update in this statement. Okay, I do an update over here, the grade 9 is changed to grade 10 now. Okay, so what was the row earlier? Row was 9. Okay, the roll number was 9. Maybe name was, maybe I put it Arnav only, and grade was 9. Okay, now the row is 100. Okay, so now this row is being overwritten by this. Okay, this is our understanding, but in Postgres this is not there. Okay, so now this row becomes a dead row. Okay, and this is a row, active row, or we can say just a row. Okay, so now this has become a dead row. So now this row, which is 9, is not deleted from the database. Okay, it stays in your buffer, it stays in your data file, it stays as it is. Okay, okay, so this row is not, whenever an update occur. Similarly, somebody deleted any row, okay, with the maybe roll number 100. So now that 100 or now or 9, even in case of deletion also, becomes a dead row only. Okay, in case of deletion. Okay, in case of deletion only, it remains a dead row only. Okay, it does not it does not deletes from your data files. Okay, from your table structure, it does not deletes. Okay, it stays there itself. Okay, it stays there. You might be knowing the concept of undo, right? Undo. in Oracle. There is a concept of undo, and similarly might be there's some concept in other databases as well, where the previous data stays for some time, right? Like it is a kind of retention. This stays for some time for all your long running transactions that are happening in your database. Okay, so that other transactions that are happening, they can get this data, right? So somebody has started at, maybe somebody deleted this row or updated this row. Uh, at 10 a.m. or assume something at this time, and somebody started his transaction at 9:59. He should see this row, right? He should be able to see this row because he started somewhere before this. Okay, so he should see this row. Okay, and there would be other factors as well, where it might be needing all the previous data as well. So for satisfying all these needs, the data is not physically deleted, okay, till the time all the transaction that are accessing this table has an SCN, or there is similar transaction ID term, XID, in Postgres, is smaller than this transaction ID. Okay, if any transaction is still running which is smaller than this transaction, this row will still there. Okay, what will happen after this transaction, or there is no longer any transaction before this data will has to be deleted. Okay, so there is a vacuum process, okay, known as the auto vacuum process. Okay, which is always running. Okay, it is continuous running, just like your BG writer or val writer, all this process, it is running. This process is always running. So this process is always running and checking on all these dead rows. Okay, it's checking on all these dead rows. Where are the dead rows is, and this row is not needed, it'll go ahead and remove it physically. Okay, it'll go and remove it physically. Definitely, this will cause fragmentation. Okay, definitely this is called the fragmentation, and fragmentation. Okay, this is a very absurd term, but yeah, this is what is occur in our stomach also. Okay, so this is bloating. So name given in fragmentation in Postgres is bloating. Okay, so this is auto vacuum will cause fragmentation, and this is known as the bloating. Now this comes the maintenance job, but how to remove the bloating and other stuff. Okay, so I hope this is clear. If you have any question, you can put it on the chat window, and in the end of the session we can discuss. Maybe just so that you don't forget at the end of the session.
Hey, Anna.
Yeah.
Yeah, we can wait till end of the session, the questions, but uh, so we are still discussing architecture only, right?
Yeah.
Yes or no?
Yes.
Okay, go ahead.
Okay. So PGCTL is a process. Okay. Okay. I'm just going through the slides now. So Postmaster is the parent of all Postgres process. Okay. So PGCTL is a utility that will create your database cluster. Okay. It's known as the Postgres control that will start and stop your database clusters. So when you do a PGCTL start, it allocates a shared memory in the a shared memory in the memory. Okay, starts various background processes, starts replication. The replication is there, background worker process if necessary, and waits for the connection request from the clients. Okay, this is very self-explanatory. When you do a PGCTL, will first start your processes, will link with your files, and will start working. So whenever receiving a connection request from clients, it starts a backend process. Okay, it is known as a backend process or a Postgres process. What does it means is, if you see this previous diagram, whenever a connection comes from a postmaster, connection comes to the postmaster, it will start a backend process, and it will give a backend process to the shared memory to take care of. I think there is a similar term like a server process in Oracle. Okay, so whenever a request comes from client, it will give it to the shared memory. It will start a process known as a back end process. Okay, also known as Postgres process. Now he will take care. Now, if he need that person or that session need not to go through the postmaster again. he can communicate with shared memory and everything with the backend process. Now backend process will be responsible to read from the data files also. Okay, to do all the stuff for particular session. Okay, so by default port number is 5432. Okay, definitely you can change this port number. Okay, anytime you can change this port number and start your cluster once more. Okay, one more thing is the cluster doesn't have any name. Okay, it doesn't have any name. Okay, this cluster which is containing of shared memory, postmaster, all these processes, and maybe number of databases does not have any name. You don't give any name to this cluster. You just give a port number to that cluster. So every cluster is identify its port number and its data directory where its configuration is being stored, where its configuration files are stored. Okay. Then you provide the port number and you provide the data directory. Okay. So backend process, which is also called a PostgreSQL process, it's started by the Postmaster. Okay, I'm just going through the same thing for each client request and handles all queries issued by one client. Okay, it communicates with the client by a single TCP connection using semaphores and shared memory and terminates when the clients get disconnected. Okay, so this is making a connection to the client with the TCP. So this is started by the Postmaster process. As it is allowed to operate only on one database, you have to specify a database you want to explicitly get authenticated with the username password. Maybe it's in the same cluster, but different database, you have to make a different connection. So it can only connect from to one database itself, okay, at a time. Okay, Postmaster allows multiple clients to connect simultaneously. The configuration parameter max connection has a default value of 100. So you can just assume it was initially not made for a database for with a huge consumption. Okay, the even the default is 100 definitely, and the live environment 100 is very less. Even in 100 there would be couple of connection only for the um, a Postgres user. Okay, that is the master user for the Postmaster, for the Postgres. Okay, so user connection would be anyways would be 98 or 97 kind of. Okay, so anyways initially it was not built for such high consumption, but now definitely databases are getting big on Postgres and users are also getting more. Okay, and more than even MySQL. Okay, so you can definitely increase it to 1000 without any worry. Okay, it supports, and in my environment also I've kept the value of 1000 and it is working quite fine. Okay, there are more than 500 connections also sometimes I see. Okay, and the database size is around 3 TB, which I am using, 3 to 3.5 TB. Okay, so and that is also performing good. Okay, so vacuum anyways we will be covering in one of these in one of the chapter. Okay, in one of the chapter of so I am just telling you there are different options of vacuum, so not going to much details. We will be covering this vacuum full, vacuum freeze, vacuum. So vacuum full and vacuum. So vacuum is one thing which I think I already told, right, that it is cleaning up your all your dead rows. So vacuum full, there is one more term which is the vacuum full. Okay, so vacuum full, what does it does is normal vacuum will create a fragmentation, but vacuum fill will not create a fragment. Vacuum full is a term which is very similar to rebuild. Okay, it is going to rebuild your complete table. Okay, rebuild your complete table. So this rebuild it will start inserting your table from the scratch, building one more kind of a temporary table, and start building your table from the scratch, so that it removes all the dead rows and it also removes all the fragmentation. Okay, so there is a term of vacuum full. Definitely this vacuum full will create a lock, okay, on the table. Okay, as of now there is no such feature that it doesn't creates a lock. It creates a lock on the complete table, so not suggested to use on the weekdays or when the database is getting used. During outage or weekends you can use vacuum full. Okay, so I think we already discussed these processes. Anyways, going through one more, background writer. Background writer is writing the dirty pages on the shared pools to the persistent storage on a regular basis. So these regular basis is a checkpoint. So checkpoint is a trigger for writer process to write dirty pages to the disk. Okay, so vacuum, auto vacuum launcher, auto vacuum worker process are invoked for vacuum process periodically. So it's come somewhere around 4 to 5 seconds. Every 5 seconds it comes and runs it. So but every time it runs, it takes some time, right? So and you will always find it running only. Okay, if you do a ps minus ef grep, okay, on a Linux machine, this process you'll always find it running. Okay, because it automatically runs at every 5 seconds. You can change this value also. A 5 second very short period. So and definitely when it will run, will do some task. Okay, by the time it remove some dead rows, is again started. So kind of it will be running every always. So one more background writer process is there, bg worker process, that is used for replication. If you have configured any standby system, so this process would be there. Val writer is a process that is writing, flushing the data from the val data to the val, from the val buffers to the persistent storage. Statistics collector is a process which is collecting your statistics of particular table. Okay, which is you can store the statistics in pgstat activity or pgstat database. Okay, so these statistics get stored over here. Okay, so collection of statistics of the tables or indexes means is what is the size of the table, what are the number of rows in a table, what is the cardinality of particular table or row or column. Okay, there are different factors, free spaces, all different factors would be there in the stats. Okay. Of the particular table. So this is would be statistics collector. Okay, then is the logging collector, that is writing the error messages into log files. An archive process, that is to move the writing the archive files from the log files. So any questions till now, and any process you can put on the chat window.
Yeah, Anna, I have so many questions. You want me to wait till end of the session, or you want me to ask?
You can ask whatever is being taught right now. You can ask. Yeah, Vinod, you can ask. That is fine.
Yeah, can you go to the main screen?
This
The
one?
first page. Yes.
Yeah, yeah.
So when it comes to wall segments, right? So whatever
You can increase the size of your val files. Okay, that is there. I didn't got your next question actually. What do you mean by this transaction ID? Can you repeat that question?
Yeah, so basically it's about the vacuum full, right? Like
Uh,
regarding the dead row.
mm-hmm,
So let's say that, the dead row, like the data change is almost a gig of the data, let's say 1 gig or maybe 10 gig or something like that.
mm-hmm.
So what will happen? Like, will the vacuum keep waiting and the this where this
Okay, I hope that is all right as of now. Okay, let's do a couple of slides more, and then yeah.
MB you have seen something like that?
50 MB is the standard, because you said there is no multiplexing also. You the risk of losing also data if you keeping it more
Yeah,
and more.
that maybe that we'll discuss in that backup and recovery section maybe.
So there is a
The
risk of
size part, I think it should be depending on the size of the database and the memory allocated, isn't it? There is no defined size what you can mention.
no 16 MB is the default size if you create a cluster. Okay, if you create a cluster, don't specify any parameter. 16 MB is the size. Okay, so you can change this size once your database is created. You can change this val segment size later on also. Okay.
Okay.
This was telling the 16 MB is the default size, and you can change the size. Okay, you can make it 50 MB or 16 and keep it 16 MB, because val segments is multiplexing of val segment is not there. The size, the more size you increase, and if any case corruption occurs, assuming, okay, yeah, then there is a risk of losing those data. Okay, maybe you can take a backup immediately once this corrupted, but assume some disaster happened, kind of, then the risk of lose of data. Okay, because the multiplexing feature is still not there. Okay, so archive would not be created for that particular val file. assuming till the time it is not full. So the more the size it is, the more there is risk of losing of the data. Okay, so you have to balance on tuning and on balance on on the security, or you can, or what do you say, the data reliability kind of. Okay, so on both the things you have to balance. Okay, you cannot make it bigger, very big size, and then you risk lose on that 200 MB or 500 MB of that data, particular data. Okay,
Makes sense.
yeah. Okay, so next is the okay, maybe we'll end up over here on the memory part. And today, so each process will have a shared memory, like all the session, all this for all the session, the memory is shared, right? I told you all the session memory is shared. Okay, all the session memory is shared, but each process, each session will have its own private memory as well. Okay, each session will have its private memory as well. That is somewhere around 4 MB. Okay, somewhere around 4 MB. This 4 MB, don't it is a limit. Okay, you can change for particular session, and you can change overall for the cluster or for a database or for a user. Okay, so this is known as the private memory. Okay, what this private memory is containing? This private memory is worker memory. Okay, this worker memory is used for sorting of tuples. Okay, rows is known as a tuples in Postgres. Rows are known as tuple. So for order by clauses, distinct operations, for joining, for hash joining, all such kind of operation is done by in the worker memory. Then there is a maintenance worker memory. In case you are doing some manual vacuum, then this memory is being utilized. Okay, not the auto vacuum which is done by the Postgres, but if you are doing any manual vacuum, then this memory is being utilized. Temp buffers, if you are any storing of any temporary tables, so this all comes into the private memory. Okay, into the private memory, which is generally by default 4 MB, but assume you want to do some vacuum processes, so 4 MB might not be sufficient to take a longer time. So for particular session, you can increase those memory. Okay, this will cover in the performance tuning chapter.
Oh, one second, Anna. When you say private memory, right? This is for one session, right?
Yes, one session, particular session.
Okay.
Okay, so this is for particular session. Okay, and one particular session, one particular pool will be created for every session. That is 4 MB pool will be created for that particular session, and to use it for its private needs. Okay, but he would for order by clauses, distinct clauses, for all these clauses needed, and if you want to increase it, you can increase it. Okay.
And if this private memory is not sufficient, then it what happens?
That process becomes slow.
No, like in Oracle, we have temporary table space like that, right? PG aggregate target. So like that, what happens?
Yeah, there are temporary files as well. There are temporary files as well.
Okay,
I'll go through this. There are temporary files as well. So there are shared buffers. We already started. There are shared buffers which loads pages and within tables and indexes from the persistent storage to here. Okay, and then there are val buffers. Okay, to ensure that though no data lost has been occurred by the server failures, Postgres supports the val mechanism. So val data also referred as the xlog. Okay, xlog, and earlier even the directory name was xlog. Okay, now it has been changed to val. Okay, I told you, I think before 9 it was xlog. So commit log is also a memory area which is keeping the state of all transactions. Okay, now this is also very important, and this is used by the vacuum process as well, to keeping a track of all the transactions that are happening in your database, which are committed, in progress, and aborted, the transaction ID of each database kind of. Okay, so this is all about your memory structure. I think we covered the memory structure. Then we'll go more on the database side, on the data files and other things, how to create a database cluster. Okay, what are different databases? Maybe on tomorrow. Okay. Okay, so any questions on the course and something maybe you can
Yeah,
I think everybody has my WhatsApp ID. I think Ashutosh also pinged me on the WhatsApp, so you can check me on WhatsApp as well. Okay, and if you have any questions on the course, and maybe you can join by today to continue from the tomorrow sessions. Okay, anything else, Vinod? You want to ask something?
Please.